Vice President and Chief Marketing Officer of Denodo. He's going to speak about data lakehouses, the hype reality, and why you still need a logical architecture. So with that, I'm going to turn it over to Ravi and just remind the audience, please send your questions in, and hopefully we'll have more time than I left my audience in the last session to answer questions. So take it away, Ravi.
Thank you, Wayne. Let me go ahead and share my screen. All right, so hopefully you're able to see my slides. Okay. So let me move the video control out of the way. All right, so today my topic is on data lakehouses. So I don't know how many of you have actually listened to it or heard this particular term. It's definitely something that has come up just recently. And in this session, I want to focus on what the hype is and where the reality lies. And in spite of all these new buzzwords that come about, why you still need existing logical architectures that have been proven and have been used for a very long time to carry you through in your task that you try to accomplish within your company. So interestingly, when I started Googling lakehouses, the first thing I basically saw was a movie back from 2006 by Keanu Reeves and Sandra Bullock. So if you haven't seen it, I haven't seen the movie itself, but just looking at the trailer seems like a very interesting movie of two different time zones. Anyway, so that's interesting to kind of kick it off. But let's talk about like the data lakehouse and the hype related to it. Now, when you Google up Lakehouse, you will see these are basically the vendors that are pushing this particular terminology. So you see Snowflake kind of coming up as an advertisement at the top. You see Databricks as another vendor that's actually coming up at the top, and both have actually sponsored ads, which means they are spending the money to promote these terminologies. And then you also see some organic results, from AWS, for example. And you notice here that there is no uniformity in terms of even the terminology. Like Lakehouse is as one word for Snowflake and for Databricks, whereas AWS breaks it out into two separate words. And then also Google proposes, what are the other types of queries that people search for? And if you see, one is there is BigQuery, so people are kind of querying to see if Google basically provides that. There is confusion between like data lake and lakehouse. They're kind of asking data lake versus lakehouse. And Azure data lakehouse, some people are seeing if Microsoft is offering this as well. And in some cases, they are Googling up the difference between a data warehouse, a data lake, and a lakehouse. So there are multiple different variations that people are trying to understand. And also Gartner shows up in here as well as the analyst firm, whether there is a particular definition from a renowned analyst firm that actually talks about this particular terminology. So there's a lot of confusion in the marketplace, and people are trying to get a handle on understanding what exactly the lakehouse means. Now, let's step back a little bit and look at the evolution of all the data in the last 40 years. Okay, so back in the 1980s, when all the things were spindle and so on, came the data warehouses pioneered by Oracle and IBM, and they became the structured way in order to store the information so it'll be easy to retrieve. And it was so popular back then that the databases basically multiplied multiple different ones, adopted by applications like SAP and so on that were actually running on top of it. Then you had like Sybase, FoxPro, and all these guys kind of coming up with the different databases. And quite soon, people basically lost the identity of having a single place where they can store all the information. So they resorted to have all these different databases pulled into in the 1990s for analytical purposes into a data warehouse. So the data warehouse is about 30 years old, and it was born in the 1990s. And at the same time, they had ODS, Operational Data Store, for storing some of the operational related data. So there was a need to have this data unification across these disparate systems, whereas when there are multiple different places, multiple different things, chaos reigns that you can't really find the information. So came the millennium, and at that point, the structured way of storing the information quickly became outmoded in the sense that a lot of unstructured data started coming in. So you had social data coming in from Twitter and Facebook and so on. cloud started coming on board, and object storage and storing all the information in the cloud. So quite soon, the data warehouse, which was originally thought as the single source of the truth for all the information, could no longer hold all the information, because it could only hold the structured information, and unstructured information could not be put in there. So that's when, in the 2010s, the big data basically came in as a way to store the information both from a data warehouse with structured information as well as unstructured information as one place you can actually keep that information, And Hadoop was the dominant technology at that particular point. From there, it kind of moved on to creating data lakes, and there were variations of Hadoop that basically came on where you could store both the structured and unstructured information. And the idea was to store the information in its raw format and format it at the time when you retrieve it, as opposed to a data warehouse where you store the information in a structured fashion, so it is easy to find it in the first place. But the idea of trying to get a hold of a single repository to store both the structured and unstructured information did not materialize, because all these data lakes, quite often kind of failed, in the sense that Gartner said only 17% of the data lakes became production live instances. About 83% of them failed. And nevertheless, even the ones that went successful, there was no single data lake. So there was this concept of a financial data lake or a marketing data lake. So there were these multiple different versions that came about. And then now we are seeing like the lake house concept kind of come in, because one, the shortcomings of the data warehouse, unable to store unstructured information, and the shortcomings of the data lake, where it is difficult to find the information, was basically they were trying to blend the best of both worlds and come up with this terminology of lake house. Now, if you look at the data warehouses and why they were very successful, so you can see the growth in a decade. They basically more than doubled in terms of the implementation, people adopting it. And the reason is it was a structured way to put the information in so that it is easy to get the information out. So getting the information in a structured way is difficult. It takes time. Setting up a data warehouse can be anywhere from 8 months to a year and much beyond that. So it is difficult, but it was easy for the reporting tools to be put onto the data warehouses to get the information out. So it is like, in your home, you keep things in an organized fashion, all the kitchen related stuff you keep in the kitchen, so on. So when you need things, you can go there and find them. If it is all kind of dumped into a garage, it's very hard to find all these things. So that was the success of the data warehouse, but it was difficult to put the information in. And again, the structured information repository could not hold unstructured information. On the alternate side, if you take a look at the data lake project, so here is where Gartner says that 80% of the data lake projects basically failed to deliver because inventorying and curating the data proved to be biggest inhibitors of analytics and data science success. So it is like taking all your things from your home, putting them into a garage, and when you're ready to eat, pick up your tables and chairs and set it up, and you want to eat, or when you want to sleep, pick up the bed, come set it up in your bedroom and sleep. That doesn't happen, right? So we keep things in a structured fashion. So this basically did not really work out as the enterprise repository. And if you look at the hype cycle, like Gartner has multiple different hype cycles. So this hype cycle that you see from 2017, you can see that, so this is the data management. Gartner has multiple different hype cycles. You can see the Hadoop distribution that I've kind of circled at the bottom. So you remember the Hadoop kind of came into picture sometime starting in the early 2010s, but then it became more prominent with Cloudera, Hortonworks, MapR, and so on in the early part of that. And by 2015, things started going down, and you see the Hadoop distributions crossed out with the X, which means that this technology is rarely used. It became obsolete before it can even become a mature technology. And if you look at what happened to that particular market, it basically imploded. So first, Cloudera acquired Hortonworks, which for a growing market is not a good sign, because either in a mature market, companies join together, or if it is not mature, then basically they're trying to survive because the market itself is declining. There is not enough market for independent vendors. They have to kind of combine into one. And soon after that, MapR basically kind of went out of business. And it was kind of unique because This was in 2019, very specifically when I was in India, and MapR in the Gartner Data and Analytics show, they were supposed to be exhibiting on the day of. They basically did not show up for the booth, and that's when we heard that basically they laid off the entire workforce. And eventually they were not able to raise the funding, and they were acquired by HP. And just recently, I don't know if you have seen the news, Cloudera was again taken private because they were not able to sustain from a public perspective in terms of supporting all their KPIs and ROI in terms of the stock growth. So this market has kind of imploded itself because of all the challenges that it had. So similarly, if you look at the same hype cycle, but from 2020, you will see here that the data lakes is still, the Hadoop as transformer data lakes, but it's in the same proximity of where it was compared to the Hadoop distribution. And you can see that it is still in the trough of disillusionment. It is far away from becoming a very mature technology. And at this point, the indication is that the technology did not live up to its inflated expectations. So, so this is a challenge for companies such as you that are implementing these technologies. So now, Gartner has a very good structure in a 2x2 in which they talk about like known questions and known data. So if you know the questions, you know the data, and then that's your data warehouse. So you ask a question, how much, which are my most profitable products in the last 5 years, and boom, you get the answer. But if you don't even know the data, you don't know the questions to ask, that is the unknown part. And then you put the data into a data lake, you let your data scientists loose so that they can actually figure out the questions even before they can be answered. So that is that part. Now you see that orange part in between, there is definitely overlap between the two. So there were vendors like Cloudera that were actually promoting that you can actually do analytics on the data lake itself. And that was like a failed proposition. And many companies that dumped their data warehouse in the promise of trying to set up analytics on top of data lake basically went back because that did not really work out. So you see that overlap between those two intersections in this like a Venn diagram in which they are talking about the technology is overlapping. Is that the data lakehouse? So let's take a look at that. So so kind of talking about it from a hype perspective, definitely the lakehouse, the data lakehouse is on the peak of hype. Not a very well-known term, not very well defined, couple of vendors pushing for it, and there's a lot of confusion that basically reigns. So let's take a look at the reality right now. So again, let's look at what the definition. So what do they mean by a lakehouse? So here you see a couple of definitions, again, a little bit different from each of the vendors. So Snowflake talks about it from a solution concept. So it is not even a defined architecture. It's a concept at this particular point that combines the elements of the data warehouse with those of the data lake. So that's a very high level. And if you take a look at the Databricks one, it talks about as an architecture, it's a data management architecture that combines the flexibility, cost efficiency, and the scale of data lakes with the data management, blah, blah, blah. So ultimately what it means is that they're trying to pick up the best things from the data warehouse, which is storing information in a structured way. But the data lakes definitely had that cost advantage. It was very cheap to actually store the information in a data lake compared to that of a data warehouse. So they're trying to marry the both of them together. Now, this is not a new concept. So that's where I want to focus on the reality. So Gartner has had this concept called the logical data warehouse. So you know the physical data warehouse, Teradata, and all those ones in which you put the data in and you do the analysis on top of it. But the logical data warehouse is a concept that came about with the transition from the data warehouse to the data lakes, and then the challenges associated with that. So this chart is similar to the one that I showed, where I showed like the databases in the 1980s to the data warehouse in the 1990s to the data lakes and the Hadoop system, the big data in the 2010s and so on. So here in a similar way, you see 1980s pre-enterprise data warehouse, there were all the databases. So all that were multiple fragmented kind of repositories. Then there was a unification that came about in the 1990s with the data warehouse. And from there, in the 2010s, it basically post-enterprise data warehouse, It branched out because the information, unstructured information, could no longer be held within a data warehouse. So they had to put that into a data lake. So the data lakes came in, and the data lake did not become the one single repository. So they had to have a data lake and a data warehouse, and in some cases, multiple data lakes. So again, information bifurcation. So now Gartner is talking about bringing them all together from a logical perspective. You see down at the bottom where they say connect and collect. So the collection is where you move all the data into a physical repository, whether it's a data warehouse, whether it's a data lake, and so on. So it has been very hard to find a single repository where you can store the information, and replication is a bad thing. So here they're advocating connecting to the data wherever it is. If you have your existing data warehouse and if you set up a new data lake, plus your applications on the other systems on the cloud, leave them where they are. Connect them and do a logical unification to gain that single view. Having the information in a central place is definitely valuable, that you can actually find the information easily. But if they are siloed in different places, it's very hard to find. Again, moving them physically into a place does not work. So go in for a logical integration of the data, and that's the logical data warehouse concept. And here is from an architecture perspective. So what are the technologies that go into the data logical data warehouse architecture? So down at the bottom, you see data fabric, data virtualization as a way to integrate the data across these multiple silos. And then again, on the top, you see data virtualization and the federation to deliver the data to the consuming systems, either through APIs, through the reporting tools, even for your data science and so on. So it is a way to get the data across these multiple repositories. In between, you see the data warehouse, the data lakes, and so on, and deliver them. So the data virtualization comes in as a key piece within that. Now, here is another architecture for the data lake. And even in this, like, the data kind of comes in from the structured, you see the data warehouses and unstructured information that come into even streaming information that actually comes into this central repository. And from there, you have data virtualization, pick it up and then deliver it to the consuming systems, whether it's applications, portals, or BI systems. So data virtualization is the key technology, whether you're using a logical data warehouse or a data lake architecture. So that way you can have that logical unification of the data rather than having to have them physical, which did not work. Okay. And if you have not heard about data virtualization, there is a technology that has been around for the last 20 years. And you can see it as a mature technology. It has already reached the plateau of productivity. And so has the logical data warehouse, which contains the data virtualization as a core part of its technology. So this actually signifies that there is very low risk in these technologies because thousands of companies have actually implemented them very successfully and they have benefited from that. So let's talk a little bit about why you need a logical architecture. Now that we have seen the reality, we saw the hype with the Lakehouses. The reality is that you still need a logical architecture. Doesn't matter, whichever terminology the industry basically invents. So data virtualization is a very mature technology. And one of the key aspects is that it acts as an abstraction layer between the underlying systems. They could be spread across any different places. It could be, the data could be in any format, structured, unstructured data, and it could be in any latency. It could be data at rest, data in motion, doesn't matter. So the data is disparate and wherever it is. The business users at the top, they really don't care where the data is. They want quality data in real time that they can act upon right now. So the data virtualization layer basically provides that abstraction between the two, where the business users come to the data virtualization layer and ask for the data, and in turn, the data virtualization layer figures out where to go get the data from, irrespective of the location, format, or the latency. That's a key principle. I've not seen any technology do that in my 30 years of experience. And it does this logical data integration without replication. Replication is bad. The moment you replicate the data gets out of sync. It's very hard to find the information because not all of it is in the same place. And it creates a lot of challenges related to it. So the data virtualization provides the data in real time. It doesn't store the information. It contains the metadata about where the information lies. And when you request the information, it goes and gets it from the real time. So the data is as fresh as it is authored in the sources. And because it is the enterprise data layer, it can catalog all the information. So it's very easy to search for the information. You can go and search for all instances of a John, and it can tell you it is coming from the CRM system, from the point of sale system, and so on. And it can actually show all that information. So it has unified metadata, it has unified security and the governance, because it's a single place where you can actually set that all up without having to set them up individually across the different applications. And the best part is in the data delivery, where you can deliver the data to the consuming systems and the users in any format that they like, whether it is APIs or in SQL queries or whatever. So that's basically what a data warehouse, data virtualization basically does. So to look at it a little bit deeper from an architecture perspective, it uses three principles: connect, combine, and consume. It connects to the underlying sources, combines the related information. For example, if you're asking a query, give me my most profitable products in the last 5 years, it can actually look at the customer information from the CRM system, the product information from the PLM system, and the point of sale information for all the transactions, combine that information and answer that query very fast. So it provides that combined information with all the related connections to the consumer. And the consumption is where you can consume it for multiple different use cases, for your BI use case, for your data science use case, for data exploration, discovery, and so on. So in this case, Denodo has connection to over 150 different sources, whether it is structured, unstructured, on the cloud, in the cloud, or on premises, and so on. And in between, it has a lot of capabilities from a self-service perspective to be able to, for the users to get the data themselves. You don't need to go to the IT every single time you want to get the data. It can run both in a hybrid as well as a multi-cloud combination. So the data that it integrates can reside on premises or in the cloud. So it can still combine the information. Or it could be across multiple different clouds. It could be sitting within AWS, Azure, GCP, and so on. It can integrate that. Since it's a central place for managing the data, it has strong data governance that you can actually lock it down in terms of who's actually allowed to see what and what there's and who's accessing what. And it does this all very fast using the query optimization. Quite often there is a concern whether the data that actually comes out of data virtualization is very slow because it's accessing all in real time. But the analogy that I would give here is that, let's say you want a cup of water, and either I can carry a big barrel in which I'm storing the water to you and give you the cup, or I can just take the cup, fetch the cup of water and bring it back. Which one will be faster? Fetching the cup of water will be very faster. Like that, data virtualization, your CRM system could have millions of rows of data, your Hadoop system could have billions of rows of data, but your result set, if you're asking my most profitable products, how many products are you going to have in a company? Hundreds, thousands. So the result set is only that many rows. So data virtualization actually reduces that in the source systems itself and provides just the result very fast. And that's why the query optimizer is a very important component. And nowadays, the data virtualization comes with a lot of AI ML capabilities because it learns how you operate with it. It learns and automates a bunch of functions. It provides recommendations. So it simplifies your tasks. It provides you views that you cannot see. It's just like having like a rear view camera when you back up the car. So kind of letting you know what is out there. So it provides all that information. And the final thing is, from a security perspective, it can lock it down in a central place so that the underlying data is protected from anywhere anyone comes to access that information. And from a consumption perspective, it provides a data catalog where you can actually see and discover all the information that is in the underlying systems in one central place, without having to go to multiple different systems to search for the data. And the BI tools, any type of BI tools that you can actually connect to the data virtualization layer and consume it. And data virtualization, in fact, provides a unified semantic layer. So you don't have to set up this semantic conversion in each of the BI tools. Set it up centrally within data virtualization and do the democratization of any reporting tools that your business users can use. Use it for advanced analytics using data science. You can run your R, Python, and so on right on top of the data virtualization layer to get the information. And data virtualization by the enterprise data layer provides all the data. So your data science tools need a lot of data in order to run the different models and the regression in order to come up with the best answers. So for that, you need all the data, and the data virtualization layer provides it. Or you can actually expose the data objects as APIs so that you can build applications on top of it. So there are multiple different ways you can consume. So connect, combine, consume is how the data virtualization works. So let's take a look at the use case about a customer that's actually using data virtualization, logical data warehouse, or lakehouse, if you will. Prologis is the world's largest property owner. Not many people have heard about it, but if I tell an associated name, you might. They are the people who own and manage the physical warehouses, not the data warehouses, the physical warehouses for Amazon. Amazon is the world's largest retailer. And any product that you order, you get it if you're a Prime member within a couple of days, sometimes within a day, even the same day. And that's because they have it somewhere locally in the warehouse that they can deliver. Now, Amazon doesn't own these warehouses, they lease them. And that's where Prologis comes into picture, where they build and manage and maintain all these physical warehouses for Amazon. By that nature, they are the largest property owner in the entire world. So they set about their BI architecture. They were using all the traditional data warehousing tools, as you can imagine, the amount of data that they may manage with all this, with one client itself. They have other companies also as customers. So it is difficult for them to manage all that information in a central place. So they were spending a lot of ETL to map the data across the different data warehouses and the consuming systems. It was not very sustainable. So they wanted something more advantageous, and also to be able to combine unstructured information with the structured information as well. So that's where they used data virtualization as a way to combine the information across these multiple systems. And you can see they have been transitioning from their traditional data warehouses to cloud data warehouse, in this case, Snowflake. And again, as we talked about at the beginning, Snowflake is promoting their promoting their technology as a lake house. And so you can call this as a lake house. So even if you have a lake house, you will still need logical architectures like data virtualization to, one, integrate, take the data from the lake house, plus all of the data that is not resident in the lake house, combine that to gain that unified view, and then provide it to the consuming systems, which is like Tableau and other systems that consume the unified information. And they were able to accomplish this even for the data science project. So down below, you see AWS, Lambda, Jupyter, and so on. So they use, they have built some models that actually do some cost and price optimization, for which they need a large set of data. And once the data is actually fed in, and the models are built, then they expose this model again through the data virtualization. Remember, when you saw the logical data warehouse architecture, there was an integration aspect of bringing the data from the silos. And then data virtualization was also used for the delivery to the consuming system. So here they use data virtualization for integrating the data to feed their AI models. And once the models are built, they're using data virtualization again as a delivery layer to their business users, again through Tableau and so on, who can use that to price their the warehouses to their clients. So here is a quote that actually comes from one of our sponsors. The speed of business is faster than before. It is now critical to be able to make decisions on a dime to pivot business in its needed direction. So that's why they went with the Denodo platform. So that's a great attestation. So let me kind of summarize. We started talking about the lake house, and there were three sections that I covered. The first part is basically trying to talk about the hype itself. So lake house could be a viable concept. I'm not disparaging it. I'm not throwing it out of the window. But it's a term du jour. It might stick. It might not stick. We never knew. Back in 2010, if you had to say Hadoop is going to go away in 2010, nobody's going to believe it, because there were companies that were founded like Cloudera and so on that were pretty strong in the way they came. But now looking back, what happened to them? So same thing, Lakehouse, could be sustained, might not be sustained. We don't know. So you don't want to buy into that particular hype and reset your existing needs. So what you want to do is still you need the logical architecture. So that is the second part that we talked about. So which has been around as a way to unify the data, because the goal, whether it is a data warehouse, a data lake, or a lake house, we want the information unified across the entire company. So that way we can do very many things from a business user perspective. And the logical architectures have been providing that foundation for the last 20 years. And then the third part is where we deep dive into the architecture itself, the data virtualization architecture, looking at the 3 layers that connect, combine, and consume, and how you can get the data unified very fast without having to replicate it and deliver it. And finally, we saw that in the context of a customer who's actually using it, so that they can actually, so you get the idea of how they have been successful migrating from a data warehouse, adding in data lakes or lake houses, and then making that work. So the concept that I talked about is practical, and you can actually try it. So there's a free trial of the data virtualization that you can download. You can go to any of the 3 big cloud service providers, and then you can look for the Denodo, and then you can actually go ahead and download, and you can play with it. There's a 30-day free trial that is actually available. So that kind of brings me to an end to this presentation. So let me check questions that might have come up here. So
yeah, so Ravi, we got a few questions here. So,
yeah.
So let's see here. A couple ones got some good votes. What are some best practices for connecting to a data catalog in Denodo?
So the best practices for connecting data catalog in Denodo is that Denodo has the data catalog itself that it has, because as I mentioned, because it unifies the data across the different systems, it is a central place where you can catalog all the information in terms of where the data is coming from, what is the format, who actually owns it, who has actually accessed it, what are the related data items. So it contains all the information. But there are other data catalogs that you can connect to. So we connect with Calibra, with IBM Information Governance, and so on, where you might want to act upon those ones if you want some data governance capabilities with rules and email triggers that need to be triggered based on some actions. So the best practices is, like, if we look at the data catalog within the Denodo itself that actually provides the capabilities, if it's not sufficient, take a look at some of the other tools that if you already have, then you can integrate them with the Denodo, and then it shares the metadata across the 2 systems, and then you can leverage those ones as well.
Great. Here's an interesting question. Graph databases are growing in popularity. How do you see graph fitting into a logical architecture? Could a graph replace a lakehouse?
Very much so. So, right now, if you take a look at, there's this notion called the data fabric. That's another term that, Gartner has been promoting. And data fabric is, again, an architecture that actually combines the data virtualization with the graph engine, with AI, ML, and so on. Definitely, graph is here to stay, and that provides the interesting connection between the different terminologies. In fact, in Denodo, we have actually GraphQL, we have the query engine to be able to extract the data from the Denodo itself for you to see. So we have the REST APIs, which are fine-grained APIs through which you can get the access to the data, but you can have GraphQL as a composite API that can actually get access to the entire object as opposed to the individual elements, and then expose that. So I definitely see Graph as being something that would become more popular, more integrated, more so from a data catalog perspective. There are a few vendors that are actually driving down that direction. So yeah, I very much see that as part of the logical architecture.
Okay. Do you have examples of a Denodo catalog being adopted by all users?
Yeah. So, for example, Prologis that I talked about, there are a lot of other customers. So we have had the data catalog for the last, I would say, probably last 4 or 5 years, something like that. And we have, it has a business user interface. It's a separate one that actually has like a Google kind of an interface. It has a view in which you can see all the associated relationships, like the customer related to the products, related to the warranties, related to invoices. So you can see all those different associations. You can see the lineage history and so on. So we have a lot of customers that actually use it for multiple different purposes. to do the data discovery, to understand the association and relationships, and to be able to connect the data governance on top of it. So if you reach out to me specifically, I can provide some very specific examples.
So question from me on the Gartner hype cycle chart you showed, there was a red X next to data catalogs saying, suggesting that technology is obsolete. I don't understand that. Do you?
I do. So what that means is that, so each of those are individual markets. What they're saying is data catalog is a viable technology, but it is not an independent market. So the data catalog will get consumed by the different technologies out there. So if you look at Gartner, for example, their data catalog, what they have is a market guide. You have some standalone data catalog vendors like Polybra and so on, but then most of them come from other ones like data prep tools. You have them coming from data virtualization tools like the way we have. There are some data integration tools that actually have them. So there are associated technologies that have the data catalog concept, but except that it does not stand alone as a separate market like the data integration market.
Great. That does it for the questions.
Okay.
I don't know if you have any last thoughts, parting shots for the audience.
Well, time to wrap it up. Go get some drinks or something like that. Thanks for hanging in there, and reach out to me if you have any questions, or Shankar@denodo.com.
Excellent. Thank you, Ravi. Thank you to the audience for staying with us until 6 o'clock Eastern anyway. And hope you have a great day and rest of your day, and we'll see you tomorrow.
Thanks, Wayne.